And I hope I'm recording the right screen. I don't even know what screen it's recording. So we'll just hope it's recording the right screen. All right, so we talked about, let me see. The last thing we did was the rise over run. So remember we talked about this being the address. So remember X1 and Y1 is the address for one of the dots, and X2 and Y2 is the address for the second dot. Which one is, if I have one is ones and the other one's twos, like if I was looking at, let's say, let's say I was looking at this dot, oops, and this dot. Which one of these is X1 and Y1? Is it, we'll just say this one's A. Is it A or B? Which one gets the ones?
A.
A. So remember the ones are the ones that's closer to the bottom, right? And when you're subtracting them, remember it's the Y values over the X values, okay? And it doesn't matter which dots you use. So you could use these red ones, or you could use the gold ones here, or you could use a combination of the other ones. If the line goes all the way down to 0, 0, definitely use that one. That's an easy point because it's just zeros, okay? All right, so we did this one the other day and we talked about, so like for point 1, they did 5 and 10, so they used this point. And then they did 40 and 10, so 40 and 10. That is not 40 and 10. Oh, 40 and 20, sorry, 40 and 20. I'm looking at the wrong thing, okay? So the address for this, the X value is 20. And the Y value was 40. Sorry, my writing's horrible, okay? But I'm doing it with a mouse. And then for this one, the X value is 5. And then the Y value is going over 10. Okay, so that's how we get our points. And again, it doesn't matter, like I could do the same thing. I could use this 20 and 40 and use 0, 0, which would be super easy as well, because this would be 40 minus 0 and 20 minus 0. So it still would be 40 divided by 20, which is still 2. All right, so let's kind of review what we talked about last Thursday. That was a long time ago, last Thursday. All right, so remember we talked about those lines, okay? So remember, the first thing I want you to always look at, remember, was the y-axis, okay? Y-axis. All right, and so this tells us that we're dealing with speed, time versus distance. It tells us we're dealing with speed. All right, if you see time and then over here you see velocity, where I highlighted yellow, then we'll be talking about acceleration. But remember, if the line is pretty straight, for instance, like this one, this line's pretty straight. Remember, it's a constant speed versus this one is kind of curving. So this one is accelerating, okay? So it's getting faster and faster. It's like when you first, if you're at a stop sign, okay, you're at a stop sign and you hit the gas, it takes a while before you get up to the speed you want to go to. You're steadily getting faster, okay? This line is like you've already been driving and you're just going constantly at 50 miles per hour, okay? All right, so let's go to this next slide. Let's look at these. All right. Take a couple of seconds. So we're gonna go through these together. Okay, now we're just trying to figure out everything. And let's give everyone like 10 seconds to think about it, and then I'll let you unmute and answer. All right, so this one says, which graph shows a runner who started at 10 yards ahead of the other runner? So 10 yards, and yards is a distance, okay? So looking at these lines, you got these graphs, okay? So you got graph A, graph B, graph C, and graph D. Which one shows a runner who started 10 yards ahead of the other one?
A.
Very nice. Graph A, right? This guy started at 0. This guy started at 10. So he started 10 yards ahead of the other one. Very nice. Okay, so it was A. Any questions on that one? Good. All right. Now, we're going to wait 10 seconds. Okay. I want to know who is running faster, runner A or runner B. Wait 10 seconds. 10 seconds. All right, who do you think is running faster?
B.
B, you guys agree? Yes, runner B. All right, look. So they both started at the same place, all right? And even though they ran the same amount of time, 4 seconds, this runner B got way further. He got 30 distance away. His distance is 30 versus runner A's being 20. So he must be running faster because he covered more distance in the same amount of time. So yes, remember, the more, if you look at me on the screen, the more your line goes like this, starts to stand straight up, that means the faster you're going. So going fast, faster, 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 faster. Okay. All right. Next question. All right. In which graph below, 10 seconds, are the runners running at the same speed? Same speed. Wait 10 seconds. All right, who you guys got?
D.
D, all right, Lydia says D. Do you guys agree with her, disagree? I see a lot of people agreeing with her. Very nice. I agree as well. Okay. Oh, hold on. Let me trying to switch my thing here. There we go. All right, great. Runner D. Here we go, next slide. All right, let's look at these. Now, let's do this. All right, so it says match the descriptions with the correct distance motion graphs. So I'm going to give you a couple of seconds. I'm going to give you more than 10 seconds on this one. So I need to know, when is the car stopped? When is the car moving at a constant speed? Hold on, don't put them yet, Lydia. Are you putting to just me? Don't tell everyone yet. Okay. All right, which one is the car stopped? Which one is the car traveling at a constant speed? Which one is the speed of the car decreasing? And which one is the car coming back? You can private chat me. I can see the chats right now. So private chat me the ones you are pretty confident in. Okay. Mm-hmm. 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 All right, so these are looking pretty good. All right, let's see how you did. Let's see if the next slide tells me. Oh, no, it goes to this one. All right, this one means the straight line means that the object was not moving. So yes, very nice. The car is stopped. 1 and C went together. Very good, very good. Let me see if the rest of these tell me. All right. This one, the graph shows increasing speed. The object was accelerating. Very good. You guys told me on here. Actually, that's a different one. So these are, yes, but yes, on number 2, car is traveling at a constant speed. That was A. Very nice. The most thing I saw where people were kind of, most of them were right. 3 and 4, car is coming back, or the speed of the car is decreasing, okay? That can be kind of tricky. So here, the speed of the car is increasing and then it kind of levels out. So it's not really decreasing. I would say, honestly, I could see this one being the speed of the car is decreasing for sure. And I could see this one as the car is coming back. So I would argue you could do either one of those. So on this one, the distance, actually because on this one, these two aren't really great graphs. This one, the car is coming back, but the speed of the car is not really decreasing on this one. It's just kind of being constant, okay? All right, but yes, you guys got these two absolutely right. And these two, I should have probably did a different graph. Very good though, yes. All right, so now let's look at this. These are speed time graphs. So here's the difference. Now, instead of this saying distance, it now says speed. Okay, so now this says speed right here. Okay, and so that means we're not looking at distance. The car is moving, okay? The car is moving. There's some kind of speed right here, okay? So this says speed time graph looks much like distance time graph. Be sure to read the labels. It's either going to say speed or velocity on this side, okay? On this one, it says the speed, okay? This is really important. I'm going to show you the difference, okay? On this one, this says the speed is constant. It is not changing over time, okay? So let's look at the difference between this one and the one you guys just answered, okay? This is a straight line, okay? This one is also a straight line. This one says distance, okay? On this one, my distance or my position is not changing. I'm sitting in a chair. Seconds are passing. I'm not moving, okay? On this one, however, it says speed. So I'm moving, but I'm just not getting faster or slower. So this one, if it says speed time graph, this is the trickiest one, okay? You are moving, but you're moving at a constant speed. Does everybody understand the difference between the two? Can somebody tell me in their own words, what's the difference between the two? Because they're both straight lines.
If it's distance and time and you have a straight line, that means you're not moving. And if it's speed and time and it's a straight line, that means you're just going at constant speed.
Very nice. Perfect. Okay. Constant speed. I'm walking at the same speed. I didn't slow down. I didn't speed up. Very good. All right. Now on this one, this is also a speed time graph. Okay. On this one, the object is accelerating, okay? On the other one, it was moving at a constant speed, okay? Because the distance was changing at an interval that correlated to the time. This one, the object is accelerating, okay? And remember, you guys have these notes, okay? So this one, it is increasing speed, okay? Because look, if this is speed, let's just say this is down here. Let's say down here is, I don't know, 10 miles per hour. Now it's 20 miles per hour, then 30 miles per hour, then 40 miles per hour, then 50 miles per hour. I am speeding up. I am increasing in speed. That's why it's so important that you look at your y-axis, okay? That's the biggest thing I can tell you guys. Look at your y-axis, okay? On this one, it is decelerating. It is slowing down, okay? So on this one, we're slowing down, decreasing in speed or decelerating. Okay, again, this is speed, right? And then let's see what this one, all right? So this one, okay, talks about who is accelerating faster, okay? They both got to the same point, okay? They're not really quite at the same point, but we can say they're at the same point, okay? But it takes this line a longer time to get there. So this one must be moving at a faster or accelerating faster, okay? All right. So steady acceleration, steady speed, increase in acceleration, decrease in acceleration, okay? All right, not a trick question, but maybe Parker, and then Parker, if you need help, somebody else can jump in. When we're looking at graphs, what is the very first thing I want you to look at?
Is it the y-axis?
It is the y-axis. That's the very first thing. So if you did not write that down last time, that's the very first thing I want you to look at is your y-axis, okay? Y-axis. All right, let's go through some of these. These are speed graphs. Here's my y-axis, okay? Private chat me. 1, the car is stopped. 1, the car is traveling at a constant speed. 1, the car is accelerating, and 1, the car is slowing down. You guys can private chat me. Let's start with number 5. Tell me 5, tell me what graph 5 goes with. Okay. Good. Looking good on number 5. All right. What about 6? Jalen, yes. Let's see, 6. All right, 6, let me see. People. One or the other, Jalen, on that one. Yes. 7 looks good. Very nice. All right. So for those of you that were participating, all right, car is stopped. Lydia, where is the car stop? Which graph?
You said where did it stop?
For what'd you put for 5? Which letter did you do?
H.
H. Very nice. 5 was H. And then Parker, what did you put for the car traveling at a constant speed?
G.
G. Very nice. And then Jessica, how about the car accelerating?
I put E.
E, very nice. And then Jalen, how about the car slowing down?
F.
F, very nice. Good. All right. So this is another speed time graph. Let's see. Aurelia, you have from, actually, let's just let's give everybody like, let's say 2 minutes. So you're looking at this graph, you're trying to figure out when is it accelerating, decelerating, at a constant speed, or at rest. So you could say from O to A to B, B to C, C to D, D to E, E to F. Let's see. So just, you can write it down on your notebook and then we'll see how you did. Let's take about 2 minutes. All right, here we go. Accelerating from O to A, you are accelerating. So I'll color code this. Let's do highlighter. We'll do green for accelerating. All right, so from here to here, we are accelerating. And is that it? Yes? Are you sure?
No. No.
Where else?
D to D. I mean, D, my bad. D to E.
D to E, we are also accelerating. Very nice. All right, so from O to A and D to E, we're accelerating. Decelerating, let's use red for that one. Decelerating, where's that at?
B to C. B to C.
Very nice. B to C, we are decelerating. I am really bad with this mouse, okay? Constant speed, how about purple?
Your line is like killing you.
E to F.
E to, I'm really bad at this. E to F, yep, there's another
A to
one.
B.
A to
A
B.
to B, very nice.
And C to D.
And technically C to D is also a constant speed, but that constant speed happens to be what?
0.
0. So that one,
Put at rest.
yes, this is the one that's at rest. Very good. All right, quick review, here we go. And then we're gonna go right into the, if we have time, the study guide. All right, here we go. All right, first question, I'm gonna just call on everyone, okay? So just be ready to unmute yourself. I'm just gonna ask you a random question, okay? All right, I'm trying to get this where I can see. All right, Kaylee, what does the y-axis show?
The y-axis shows the speed.
Speed on this one? Show me where.
Wait. The y-axis shows the distance.
Very nice. Y-axis shows distance. Stephanie, what type of graph is this? Distance time or speed time? Stephanie, did you hear me? What type of graph is this? Distance time or speed time? This graph right here. let's see. Can you hear, we can't hear you, Stephanie. Are you talking?
Can you repeat the question?
There you go. Yeah, what type of graph is this? Distance time or speed time?
Distance time.
Distance time, very nice. All right, let's see. Anybody want to volunteer? What does this graph show? Is it showing constant velocity, acceleration, or no movement?
Acceleration.
Say again?
Oh, no. Oh, yeah.
Constant.
No. Yeah, it's constant velocity because there's no speed.
Okay, constant velocity. Let's see how we did. Oops. Try to move. All right, so very nice. Distance, time, and constant velocity. Very good. All right. Rhea, I'm sure she's on here. I just can't see her. Rhea, what does the y-axis show? Wait, is Rhea on here? Okay, we'll do Reagan. Reagan, what does the y-axis show?
Distance.
Very nice. And Harmony, what type of graph is this? Distance time or speed time? How about Jordan? Jordan, what do you think? Distance time or speed time? This graph right here.
I think it's speed time.
Speed time for this graph right here?
No, it's distance because it's going at a constant speed and it's probably going to record the distance instead of the time.
Yes, this is a distance time graph because distance is on the y-axis. And then anybody know what this one is showing? Fitzmarlin, do you know what this graph is showing? Is it constant velocity, acceleration, or no movement?
No movement.
No movement. Very good. Very good. This is distance, time, and no movement. All right. So this one says, what does the y-axis show? I think Lena, how about you? What about y-axis? What's it showing? Adela, what do you think the y-axis is showing?
Distance.
Distance, very nice. And then Faith, what type of graph is this? Distance time or speed time? Okay, Robin, distance time or speed time?
Distance time.
Distance time, very nice. And what is this graph showing? Well, let's see. What can you tell me? Can anybody tell me anything about A compared to B?
A is faster than B.
A is moving faster than B. Very nice. All right. So distance, time, both A and B are moving at a constant speed or velocity, but A is moving faster. Very good. All right. Y-axis, Glory, what do you think? Y-axis, what's it showing?
Distance.
Distance, very nice. And then Aurelia, what type of graph is this?
Distance and time.
Distance and time, very nice. And then what does this graph show? Anybody want to take a guess? Anybody? Is it no movement, acceleration, or constant velocity?
Acceleration.
Yeah, I'm gonna guess acceleration.
It is acceleration. Very good. So if it's constant, remember that line will be very straight. Okay, so like this is constant. This line is straight. If you see that line and it's curved, it is showing acceleration. Very good. Very good. All right. All right. Y-axis. Anybody? I'll take anybody.
Time.
Speed.
Wait, speed.
Speed, very nice. Speed, so you got to shift your thinking because this is now a speed time graph, right? This is a speed time graph. All right. Let's see if anybody gets this right. A, B, or C? What does this graph show? A, B, or C?
Oh,
I heard A and C. Which one is it?
A.
Let's see.
A.
It is A. Very nice. Now, if this said distance, the answer would have been C. Okay, but this says speed now, so this is a constant velocity. Very good. All right. All right, so if we're looking at this, this is just to recap again. Both of these are showing constant velocity, okay? This is what it looks like on a distance time graph. This is what it looks like on a speed time graph, all right? And then, all right, so let's see. I feel like we just did this one, but maybe not. All right, y-axis, Jalen, y-axis. Jalen, why don't you do 1 and 2?
All right, on the y-axis is showing speed, and then the graph is speed time.
Very nice. So this is how you determine what type of graph it is. All right, so now we need to determine, is it showing constant velocity, constant acceleration? Let's give everybody 5 seconds to think about it, all right? Constant velocity, constant acceleration, or no movement. 5 seconds. Let's see. The answer is very nice, constant acceleration. So remember, there really isn't a difference between speed and velocity, except for one of them has direction, right? Correct. Okay, so which one of those has direction? Speed or velocity?
Velocity.
Velocity.
Yes, velocity has speed. So technically when we're talking about velocity versus speed, I could say I'm going, actually I'll show you a slide. Let me see. I could say I'm going 55 miles per hour. That's a speed. But then I could say I'm going 55 miles per hour south. That's a velocity, okay? All right, oops, going the wrong way. Last slide. Somebody can take 1 and 2, anybody?
Speed and speed time.
Speed and speed time, very nice, all right. So is this showing, we gotta think about it. Let's let everybody think about it for a second. It's either constant velocity, constant acceleration, or deceleration. 5 seconds. I see lots of answers in the chat, very nice. Very good. I'm just going to put it up because it looks like everybody is getting it right. It is showing deceleration. Very good. Deceleration. It is or slowing down. Okay, the speed is going down over time. All right, very good. So here's what we are going to do. Discard. All right. Can you guys still see my screen or no? Do you see like rise over run? Yes, okay. All right, so I'm gonna let me just show you what it looks like. I'm going to put, can you see this? Can you see a Word document right now?
Yes.
Yes, all right, this is your study guide. Make sure you know the difference between scalar and vector, okay? And then which one of these fall into. This is distance versus displacement. This is, tell me if it's speed, velocity, or acceleration. Here's some calculations. For the test on Thursday, I will give you this triangle. Anybody want me to explain how the triangle works? It won't matter because they're right here. So if you're looking for a distance, I'm being super nice on this test, okay? If you're looking for distance, it tells you multiply velocity by time. If you're looking for time, it tells you to do distance divided by velocity. If you're looking for velocity, it tells you to do distance divided by time. So the only thing you really have to know is if you see meters you have to know that that's a distance. If you see seconds, you have to know that that's a time, okay? So there's a couple of those there. Here's, you have to tell me if it's scalar or vector, okay? What's the shortcut for knowing which one velocity is?
V.
Yes, they both start with V. So velocity is a vector, okay? What about speed? Speed starts with an S. So it is scalar, right? Okay. And then if you know if you know that distance goes with speed, then you know that's also scalar. And if you know displacement goes with velocity, you know it's also vector. There's some acceleration calculations here, and there's some graphs down here. The rest of it is graphs, okay? So I'm gonna upload that right now.
Is this
Say again?
is this a grade?
The review isn't, but I want you to do the review so you do well on the test. So it is not a grade. So I'm gonna put that right here in the review folder, okay? It's gonna be in the review folder. Let me see. Anything else? Anybody have anything they're kind of worried about? Like what are your guys' biggest concerns? So this is all we covered: distance and displacement, speed, scalar vector, velocity, acceleration, and graphs. Okay, so what are you guys most concerned with? Here's the topics again. Anybody concerned with anything that they feel rusty on? Okay, my biggest fear is that you guys are gonna be like, this is so easy, and you're gonna go too fast through the test, okay? So I'm gonna put the study guide right here, okay? But please, 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 we're gonna have, well, I'll tell you what we'll do. We'll do a really quick review, like 10 minutes at the beginning of class. And then, because the test is gonna be short, but I want you to take as long as you can on the test. Sit there, don't submit, look at it, look at it, look at it, double check your calculations, okay? If you have questions about the test or the study guide, I'm about to upload it right now. Send me a message on Remind. Yes, go review all your old quizzes, all the quizzes we took on Schoology. Go review those, the CFA. The most missed question, let me say this one more thing and then we're getting off. The most missed question on the CFA was, believe it or not, the definition of acceleration. That was the most missed question, okay? Definition of acceleration, I don't want to see that. The definition of acceleration, I'll put that on there. Just make sure, I'll put the definition on the study guide, okay? Just make sure you know it. But it has to do with a change in velocity. Change in velocity. Make sure you know your units too. Anybody know units for acceleration?
MS.
Nope.
Is meters per second squared?
Yes. MS, velocity or speed. MS, S, or M over S squared is acceleration. All right. I hope we do good on test. I'll see you guys on
Are
Thursday.
you going to post the answers to the study guide?
I am. I'm going to post the study guide and then I'll post the answers tomorrow.
Okay, thank you.
Okay. Bye. See you guys.